Okay, so section 1.4 and 1.5 is what we have for today. Section 1.4 is on complex numbers. So this slide is just really telling you that we use the square root of -1. We replace that with I so that we can work with it. So I squared is going to be -1 because if you take the square root of -1 and square it, you're going to get -1. Okay, so if you have the square root of -25, you have to break it apart to -1 times 25. So the square root of -1 is I, the square root of 25 is 5, so you have 5I. You can check this by squaring it back, and you can see how that works. All right, so complex numbers is when you have a real part and an imaginary part. So a complex number is going to look like this, where this is the real part, this is the imaginary part. You just have an imaginary number if there's no A. If there's no B, then it's not complex, it's not imaginary. Okay, that's that. Woo. I'm not going to worry about that. Okay, so adding and subtracting. You just add like parts just like you would if you were collecting like terms. So, for example, we can put the real parts together. So 5 plus 3 is 8. Put the imaginary parts together. -2 plus 3 is 1. You're subtracting, you have to remember to subtract. So 2 minus 12 is -10. 6 minus a -1 is 7. All right, pause, try these two, see if you get them right. All right, so 4 plus 3 is 7, 1 plus -2 is -1. And for the next one, 7 minus 2 is 5, and 3 minus a negative, so 3 plus 5 gives me 8. All right, multiplying, you're just going to distribute like you normally would, and remember you get an I squared to replace it with a -1. So we're going to get 14I, and then -63I squared. But I squared is really just a -1. So this is a positive 63 plus 14I. For the next one, you have 30 minus 35I plus 24I. Sorry, the whole program went away. I'm going to pause and start over when I have it reloaded. Okay, I got it back up. I don't remember where I was. I'm just going to start over with this problem. So 30 and then minus 35I plus 24I minus 28I squared. So combine these like terms. Remember that this is -1, so this is really a positive 28. That's a 9, not an 8, sorry. So you do 30 plus 28 is 58. And then combining these guys, you get -11I. All right, again, try and check. So 18I minus 42I squared gives me a positive 42 plus 18I. 20 minus 8I plus 5I minus 2I squared, so really plus 2, so 22 minus 3I. All right, Complex conjugates, just like any conjugates, your I parts are going to go away, so you just have to do front times front and back times back, and the I's go away and the sign changes. We can't leave I in the denominator of a fraction, so we're going to have to rationalize, which is why we need to know about conjugates. Alright, so remember to rationalize the denominator, you multiply by the conjugate of the denominator on the top and the bottom. So, distributing, you're going to do 20 plus 5I plus 16I and plus 4I squared. On the bottom, because they're conjugates, you only have to do front times front and back times back. Now when it comes time to clean up, remember this is negative 4 and this is plus 1 because those I squareds are a negative 1. So we get 16 plus 21I over 17. Alright, again, you try, so pause, try, see how you do. Alright, conjugate just means change the sign in the middle. On top, you have to distribute everything. On bottom, you multiply in conjugate, so front times front, back times back. This becomes a plus 3, this becomes a plus 1. So 17 minus I over 5. I think the back of the book, if you're checking answers, may write it like that. I don't really care which way you write it. Alright, principal square roots. It's just saying you've always got to pull that I out. So what that means is, this is really easier. It's a correct and an incorrect way of handling a problem. So before you can work with negatives under a radical, you have to put the I in the problem. You can't just multiply and the negative magically go away like on an incorrect side. So if I'm going to do these problems, I have to say that this is negative 1 times 9 times 2. So I get 3I root 2. And I say this is negative 1 times 4 times 2. So 2I root 2. So when I subtract those, I get 1I root 2. On part B, remember squared means that you multiply something times itself. So you have 1. But they want you to make sure that you call this I root 5 before you start doing your work. So then when you distribute, negative 1 times negative 1 is 1. You get negative I root 5, not 15. Where's my undo button? Okay. Then you get another negative I root 5, and then you get an I squared and a root 5 squared, which is just 5, so 5I squared. So this is really negative 5. So we get negative 4 minus 2I root 5. Alright, so for this last one, we're going to rewrite it as negative 25 plus. For this negative 50, remember you can do negative 1 times 25 times 2. So you get 5I root 2. And then all three of these numbers are divisible by 5. So if you divide through by 5, it looks like that. Alright, so I went through those kind of fast. Try these and let's see if you picked it up. And I'm going to move way over here for B because it's kind of running into that one. This square root of -4 is just 2i. And it said squares, we're going to do 2 of those. So 9 minus 6i minus 6i plus 4i squared, so -4. So 5 minus 12i. Alright, that is all of that lesson. If you have questions, let me know. I'm going to go ahead and just put the other one on here too. So, let me see if I can figure out what we have. So for lesson 1.5, it's all the ways to solve a quadratic. So remember, a quadratic equation is when you have an x squared. If it's written in general form, it's equal to 0. The zero product property is the property that says if you multiply two things together, then one or the other has to be 0. All right, we're going to solve by factoring. You're going to make sure that it's equal to 0, factor, use the zero product property, solve your two little equations, and you're done. I don't ever check things. You can if you want to be extra studious. All right, so this is already equal to 0. You have two terms, so looking for a GCF is a good idea. They both divisible by 3, they both have an x. Divide that out. You have x minus 3. Zero product property says one of those is 0. So you get x is 0 and x is 3 as your answers. Alright, on the next one, the first thing you have to do is move the 1 to the other side. Then we can factor. 3 terms, so we're going to guess and check. So 2 times 1 gives us 2x squared. We need a 1 and a 1. We need it to be a positive 2 and a negative 1. So 2x times 1 is 2x. Negative 1 times x is negative 1x. That gives us the right thing in the middle. Zero product property says make those equal to 0. And to solve, we get 1/2 and -1. Alright, the square root property is only going to work if you have just a squared term. So the way that it works is you get the squared term by itself. Take the square root of both sides. Remember to put a plus or minus, and you're done. So for B, we're going to subtract 45. Divide by 5. Take the square root of both sides. You get plus or minus. The square root of 9 is 3, but it was negative, so you need an add. Alright, on C, you're going to just have this guy by himself already, so we just take the square root of both sides. So x plus 5 is equal to plus or minus the square root of 11. So then you have one more step in this case of subtracting 5 to the other side. And we like to put it in the front just so we don't think that it's under the radical. Alright, so before we can use completing the square to solve, I want to make sure you remember how to complete the square. So to force this to be a perfect square trinomial, meaning I want it to factor into the same parentheses twice, we need this number to be half of this number. So if I multiplied this out, like x plus 6 times x plus 6, I'm going to get x squared, 6x, and another 6x would give me 12x. And then 6 times 6 is 36. So this magic missing number is 36 for it to work. So we completed the square by putting the right number here to force this to factor to the same thing twice. Alright, so again, we're going to do half of this linear term. And then you just square that number you got to get the magic number in the blank. All right, so using that concept to complete the square. For completing the square, you want x's on one side, numbers on the other. So A is set up correctly. B, the first thing that we would have to do on that one is move the 6 to the other side. All right, go back to A. He's set up nice and pretty. So to complete the square, we have to figure out what magic number goes in the blank. But if we put an extra number on one side, we have to put it on the other side also. So in order to get that magic number, you take x, half of the linear term, that gives you factored form. To get this magic number, you do 3 times 3, which is 9. So we have that. So we forced this to be a perfect square trinomial. We balanced so we didn't mess things up. We factored this perfect square trinomial. Now we have something that we can solve using square roots. So take the square root of both sides. Remember your plus or minus. All right, so at this point, you really have x plus 3 equals 1. And you have x plus 3 equals negative 1. So subtracting 3, you get negative 2. Subtracting 3, you get negative 4. All right, so over here, you've got variables on one side, numbers on the other. So now we're ready to complete the square. So this is going to be x minus 5 squared is what we want it to factor to, which means this magic number is 25. Take the square root of both sides. All right, in this case, there is no square root of 30, and it doesn't have a perfect square factor either, so you can't simplify, so we're just going to add 5 over there to it. And it's better to leave it as 5 plus root 30 and 5 minus root 30 than to try to give a weird decimal. All right, so the last way to solve a quadratic is the quadratic formula. So you have this. I'm pretty sure I played some songs for you in Algebra 1 to help you memorize it. So, in order to use a quadratic formula, you have to be equal to 0. You've got to be in that general form. And then you've got to label what is A, what is B, what is C. Then we plug in to the formula all of those values and simplify. So we have negative and then a 2 plus or minus the square root of 2 squared minus 4 times 2 times negative 1 all over 2 times 2. Alright, so negative 2 plus or minus the square root of something over 4. Alright, so to get the thing under the radical, you're going to do this math in your head, in your calculator, whichever. So this is 4. This is positive 8, so 4 plus 8 is 12. Then we're going to simplify, so 12 is 4 times 3. So taking the square root of those, you get 2 root 3. So now we look, and this number, and this number are all divisible by 2. So we can reduce them, and that's your simplified answer. All right, I'm going to erase that so that I can fit B on here. Well, no, because I want to be able to make a copy of this. So I'll just try to squeeze it in. All right, so we'll write A is 1, B is negative 2, and C is 2. So the quadratic formula is over here. So we're plugging into that. So x equals a negative 2, so just 2. Plus or minus the square root of negative 2 squared minus 4 times 1 times 2. All over 2 times 1. So I did the easy part, now let's look under the radical, and negative 2 squared is 4. 4 times 1 times 2 is 8, so 4 minus 8 is -4. So for the square root of -4, that's 2i. And then again, these guys are all divisible by 2. So you can just say 1 plus or minus I is your answer. Is that it? No. Oh, Pythagorean theorem. They threw this in here because there's some squares in there, but it's goofy. All right, so what's the width of a 15-inch television whose height is 9? All right, so what you have to understand to answer this question is when they give you the fact that a TV is a 15-inch TV, they're telling you that the diagonal is 15. That was a horrible diagonal. They're telling you that the diagonal of the TV is 15. So a 15-inch TV has a 15-inch diagonal. And they told us that the height is 9. We're assuming a TV is a rectangle, so it has a right angle. So they want us to find the width. So the Pythagorean theorem says 9 squared plus w squared is 15 squared. So 81 plus w squared is 225. So w squared is, what's that, 225 14. So the width is 12. And in this case, we're talking about a width, so we're not going to think about the negative. And we are dealing with inches. All right, I think that is it. Yeah. All right, so make sure you find the assignment on Google Classroom and let me know if you have questions. If any of that was too fast and you need me to do an example slower with more explanation, just email me and I'll be happy to do that.